right, let's look at linear inequalities. So before we start, we have to remember what an inequality is. Basically, it's any expression with these symbols, less than, greater than, less than or equal to, or greater than or equal to. What we've looked at so far has been equalities with the equal sign. So here's the difference. This is an equation. This is an inequality, even though it says less than or equal to, because it has that symbol, it's an inequality. So a solution of an inequality is going to be any ordered pair of real numbers, such that when you plug in that value for the x-coordinate and the y-coordinate, you get a true statement. So the graph of an inequality is going to be the set of all points that make the inequality true. And that will create something called a half plane, which you'll see here soon. Basically breaks the coordinate system into two parts. So here are the steps to graph an inequality. So first thing you're going to do is replace the symbol, inequality symbol, with an equal sign and graph the equation using intercepts. As I said before, they want us to use intercepts only for these, so that's what we're going to do. In the example, if you have less than or equal to or greater than or equal to, basically the equality as well, you drew a solid line, but if it's only less than or only greater than, you do a dashed line. So in our example, we have a dashed line. Okay. So let me start the problem and I'll worry about whether it's dashed or solid in a minute. So the first thing we have to do is first treat it like an equation. Meaning, I'll come back to the inequality aspect. We got to first plot the intercept. So the x-intercept is going to be let y equals 0, solve for x. You will get to where you don't have to show the work on these. Some people will. So 5 times 0 is 20. So 4x plus 0 is 20. 4x is 20. And of course, if you divide both sides by 4, you get x equals 5. So that is the ordered pair 5, 0. So if I skip too many steps, please pause the video. But we're doing a lot of the same stuff that we did in previous sections, so I'm just going to skip some of the steps, I think. So 5, 0 is a point. 1, 2, 3, 4, 5. All right, I'll use a point here. So now we have to plot the y-intercepts. So y-intercept, let x equals 0, solve for y. So, same equation, 4x, we're going to let x be 0. 4 times 0 plus 5y is 20. So 0 plus 5y is 20. So 5y is 20. And y is 4. And so that is the ordered pair 0, 4. 1, 2, 3, 4. Okay, so that's 5, 0. That's 0, 4. And then it said that if we have a solid, if we have less than or equal to, greater than or equal to is solid, but since we have greater than, we'll use a dashed line. Alright, so let's do that. Now in my math lab, you will be able to choose between a solid and a dotted line. Last part says choose a test point from one of the half planes that's not on the line. That's the important thing, that's not on the line. And you're going to substitute the coordinates of the test point into the inequality. I have a note here that's not in the book, but I typically use the origin because that's the easiest point to test. There's the origin. It's not on our line. Generally, it's not on your line. But we're going to test 0, 0. You can test anything you want and see what you get, and you can apply it to our problem. So if you want to test 1, 1 or 100, 100, you could do that. 4 times 0 plus 5 times 0, is that greater than 20? So what I'm asking, is this true or false? Well, 0 plus 0, is that greater than 20? Well, 0 is not greater than 20. This is false. So if it's false, shade on half plane on other side, away from 0, 0. Okay, I tested 0, 0. 0, 0 makes it false. So I'm not going to shade here, I'm going to shade up here. And the way you could shade, generally, we'll use, let's see, that doesn't show it very well. Sometimes you can use a pencil, kind of just shade in one direction like that if you want. You could color it in if you wanted to do that, but when you put in the final answer on my math lab, you just put the final answer in. So you'll graph the line, make sure it's dotted. There's a little paint can, and you put it here, and it'll paint that side. Okay? So that is linear inequality 1. Of course, we're going to build up to a system. We'll have 2 or more. All right, before we do that, let's just look at horizontal and vertical inequalities. We won't spend too much time here, but I wanted to take time to talk about it. So if you have the statement x is greater than a, or x is greater than or equal to a, you're going to shade to the right of the line x equals a. So let's do that. I'm just going to put, I guess we'll do x is greater than or equal to a. And I'll choose a is here. Okay, so since it's equal to, use a solid line. And then it says because it's greater than or equal to, we shade to the right. Shade the half plane to the right. Had it been less than or equal to, you would shade to the left. Okay? So let's look at the next one. First we're going to shade y equals b, and what I'm doing is I'm just arbitrarily choosing something. So we'll do y is less than b, I guess. So if it's less than, that means I have a dotted line. So this will be y is less than or equal to b. All right. If you have greater than or equal to b, you shade to the above. But if it's less than or equal to, you shade below. So I'll shade below. So that's the idea. Now, here's an example, very similar to what we just did. Graph the inequality y is greater than 2. So let's pretend you forgot that y equals 2 is horizontal. So remember, y equals 2 is horizontal. Since we have greater than, it'll be a dashed line. So y equals 2 is here, dashed line. Since it's greater than, we're going to shade above. Okay. like I said, if you forgot your horizontal versus vertical, you can always do a table. We did this in the last section, but basically if you want to do the table, you do x, y, then your ordered pair. Oops. In this case, y is equal to 2, so 2 will be everything for y. And you can just randomly choose things for x. So I did like 0, 1, and minus 1. That gives you the point 0, 2, 1, 2, and minus 1, 2. So this part is not required, but if you get confused about your horizontal versus vertical, or you may miss that or mix those up, just draw the line, use a table if you need, and then you can apply what we learned up there. All right, and we got one last question. This is now a system of linear inequalities. So basically, we will work it the same, but we have to do each of these separate. So I'll do the first one. We'll treat it like an equation. Then we'll shade for that one. Then I'll work the second one, treat it like an equation, then shade for the inequality. And then the region they overlap, the overlap of the two planes is the answer. Okay, so let's do that. So I'm going to start with this one. 4x plus 8y is less than or equal to 8. Okay, so the first thing I have to do, you know what, I'm going to circle it to remind myself that's what I'm looking at. So treat it like an equation. 4x plus 8y equals 8. Okay. X-intercept is, let y equals 0, solve for x. So 4x plus 8 times 0 equals 8. In fact, you could see if you just cover that one up, you get 4x equals 8, x is 2. So you'll get to where you may not have to show all this work. But if you feel like you need to show it, just do it. The tests generally don't take students the full time. Divide both sides by 4, you get x equals 2. So that is the ordered pair 2, 0. 1, 2. That's the x-intercept. I now need to find the y-intercept. All right, I'll write it out. Let x equals 0, solve for y. Basically, this is an algorithm. You just write that out, and that might help you solve it. So 4 times 0 plus 8y equals 8. 0 plus 8y is 8. 8y is 8. Of course, y is 1. So that's the order pair 0, 1. All right, so there's that. This is less than or equal to, so that will be a solid line. Okay. All right, before I move to the next inequality, I have to test a point. Again, I always test 0, 0 because it's not on the line, generally. If it is, you can't test it. But it's not, so I'm going to test 0, 0. 4x plus 8y is less than or equal to 8. I'm going to plug it into that. So, is 0 less than or equal to 8? Is 0 less than or equal to 8? Now, some students will get confused here because 0 is not equal to 8. However, it is true that it is less than or equal to 8. So this is true. Because 0, I'll just write it out, because 0 is less than 8, even though it's saying less than or equal to, it satisfies one of them, so it's still a true statement. So I'm going to shade on the side with 0, 0. Shade on side with 0, 0. Okay. Now, what I'm going to do is I'm not going to do this very dark. Okay. So here's 0, 0. I'm shading over here. I'm just going to do these lines because I'm also interested where the shaded region intersects with the other shaded region. So I don't want to get too carried away. I want to be able to see all the regions. All right, but that part's done. Now we have to take care of this other one. 3x plus y is less than or equal to 9. Okay. Do the same exact thing. Treat it like an equation. 3x plus y equals 9. Do our x-intercept. I don't think I'm going to write out let y equal 0 solve for x because I just wrote it up here. So 3x plus 0 equals 9. 3x equals 9. X is 3. That is the ordered pair 3, 0. Okay. 1, 2, 3. Here's 3, 0. All right, let's do the y-intercept. I'll tell you what, let me do the y-intercept right here so I can see everything. Y-intercept. 3 times 0 plus y equals 9. Y is 9. So that's the ordered pair 0, 9. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9 barely is there. Because this is less than or equal to, that will be a solid line again. Okay. So we connect it with a solid line. If you want to use different colors on these lines, you can. It's not required, but sometimes I like to do that so I don't confuse the different intersects with each other. All right, now we have to test the point. Another point that's not on this second line is 0, 0. Okay? You don't have to do 0, 0, but you'll get to where you don't even have to show any work when you test 0, 0. You just look at it and say, yep, that's true. I don't have to do any work. 3 times 0 plus 0 is less than or equal to 9. Of course, on the left side, we get 0. Is that true? Of course that's true. This is true. So, shade on the side with 0, 0. Well, here's 0, 0. See if this shows up. All right, so I'm going to shade left to right. Well, luckily I'm in the right spot. I was messing up. But I'm actually shading everything under the second line. So that's going to include all of this. Luckily, where I started was overlap, so it worked out for me. All right, so the final answer is the region they all intersect. So, and maybe I should write that. The final answer is the region. Stuff in case you missed it. Okay. Final answer is the region both shadings overlap. Okay. And to kind of illustrate it, I'm just going to kind of color this in, I believe. Okay, it kind of makes like this little maybe trapezoidal shape. So I'm coloring it in darker to illustrate what the final answer is. And generally with the system of two inequalities, it makes four regions. So we have 1, 2, 3, 4. So that region is where they both intersect, and that's our final answer. So do not shade until the final answer. And I'll write that in red as a warning. Warning. Because students will miss the answer. And they did the work, and it's clear they did the work, but they didn't shade properly. So only shade final answer on my math lab. Okay. Okay, so there's that.